Hello everyone. In this video we are going to talk about the correlation between the carbon dioxide increase and the global temperature rising, right? This is the second video related to the 4.4 section of the climate change. According to this graph, this is an evidence since 1880 to until 2000 plus something, like 2007. You will see the increase of the global temperature with the blue. This is global temperature, which is going up and down, but still the average will increase, and it covers something. It supports the idea with the a strong positive correlation between the increased level of the carbon dioxide and the global temperature. And here is the data collected from the carbon dioxide inside the ice cores. We will talk about the ice core after this slide. And this is the data related to carbon dioxide from Mauna Loa, which is a station for data collection related to carbon dioxide. So both of them shows like because Mauna Loa started to collect the data since 1960, around 60. So it's a little recent data collection, and it shows the increased level of the carbon dioxide. But before that, which is a little much more ancient time, so the data were collected from the ice cores. The carbon dioxide which was trapped in the ice cores, that data was collected from that type of technique and technology. Again, it covers the strong correlation between the increased level of the carbon dioxide and the global temperature rising. Okay, from here we are going to talk about a little what is ice core and how this technology helped us to estimate the level of the carbon dioxide even for 400 years ago. That's amazing, right? What you see, these are the ice cores that has been drilled and taken from the deep side of the Antarctic. To deduce historic carbon dioxide concentrations and temperatures, ice cores are drilled in Antarctic ice sheets. Vostok ice core, which is a place that these are ice cores from that area, drilled at Russian monitoring station in East Antarctica. This is an example of ice core. This is a cylinder, and this cylinder of ice collected by drilling from the bottom of the Antarctic ice sheets, with the total length of ice core was like 2083 meters, 2D, right? And this is the data collected from each ice core by showing the different layers. The core shows annual layers which can be used to date the air bubbles trapped in the ice. You see the different layers over here, and each layer can show the different collection or the different trap of different gases, especially the carbon dioxide trapped into each layer showing, and it provides the information related to each year. Analysis of the gas content of the bubbles gives both the concentration of the carbon dioxide in the atmosphere and the air temperature from oxygen isotopes. So with these two techniques, they can not only estimate the level of the carbon dioxide, but also they can estimate the temperature as well. Here is the evidence for correlation between the atmospheric carbon dioxide and the average of global temperature. In this picture, this graph showing the CO2 concentration, and it's amazingly goes back to, you see, 400 years ago, and until 1950, because after that the stations such as Mauna Loa started to collect get together or collect the information for the carbon dioxide. But before that, even until 400,000 years ago, this information was collected from ice core. And you will see that how up and down and up the level of the carbon dioxide, you can see this pattern. For each 100 years, you see this pattern for the carbon dioxide up and down, and again another 100 years, another 100 years. So each 100 years can show kind of the ice age for going between glacial and interglacial. There was a video related to glacial, interglacial. If you watch that video, you will see what does that mean. Between becoming an ice age and interglacial, this means, going from the ice age to passing that area to that age by melting the ice to another era. That would be the switching between glacial and interglacial, which shows this up and down graph for every 100 years. And this is the temperature, and the temperature, again, you can match this pattern of the carbon dioxide with the temperature from 400 years ago. And you will see the positive correlation between once the carbon dioxide is going down, even the temperature goes down. Once the carbon dioxide goes up, the temperature goes up. So it's completely covering each other. However, you should be careful or remember that correlation doesn't prove causation, but in this case, we know from other research that carbon dioxide is a greenhouse gas. And we know that there is a carbon dioxide as a greenhouse gas, so this solves the problem. The link between human emissions and atmospheric levels of CO2. In this graph, you will see that the total anthropogenic carbon dioxide emissions, which means that the carbon dioxide emissions caused by the human, and this dash shows the 46% of the total emission, and this graph shows the carbon dioxide levels from direct measurement, and this shows this dash shows the carbon dioxide levels from ice cores. Again, you will see the similar pattern between this graph and the emission. So the key point is there is a strong correlation between human emissions and atmospheric levels of CO2, right? As atmospheric CO2 levels have increased, the amount of the carbon dioxide absorbed by carbon sinks has increased. Only about 40% of emissions have remained in the atmosphere. Another thing that we can explain over here, that once the level of the carbon dioxide increased, the amount of the carbon dioxide absorbed in the sinks also will be increased. So this means that human emission will increase the level of the carbon dioxide. At the same time, the carbon dioxide which will be absorbed in the sinks include like the trapping inside the ice and in our sinks, that will be increased as well. So only about 40% of emissions have remained in the atmosphere, and the rest of the emissions will be remained in the, or will be stored in the sinks. So anyway, the key point over this graph is by the link of the human emissions. By increasing the human emissions, also the atmospheric carbon dioxide will be increased, and has been increased, and you can see this over here. Well, the global average temperatures are not directly proportional to greenhouse gas concentrations because other factors such as sunspot activity also have an impact on global average temperatures. But anyway, we can say that the increase in greenhouse gas concentrations they likely cause the higher global average temperature, that's for sure, more frequent and intense heat waves. These are some effects that you can remember or learn. Some areas becoming more prone to droughts, some areas more prone to intense periods of rainfall and flooding, tropical storms to be more frequent and more powerful, changes to ocean currents, example, weakening of the Gulf Stream would mean colder temperatures in Northwest Europe. All these effects can be estimated and can be seen because of the global temperature changes, and these are very observable